Hi everyone. Today's video is about laws of exponents. There are in total 5 laws of exponents, out of which we will cover 2 laws in this video and rest of the laws in the next video. So let's start. The first law is called the law for the product of powers. As the name is telling you, the law for the product of the powers. That means if I have the powers a exponent m and the another power a exponent n, so these two powers have the same basis a and a, but their exponents are different, m and n. So how to simplify the expressions like these? This is equal to a exponent m plus n. It means if I have to multiply two powers with the same basis a and a, we will add the exponents. That means the base stays the same, but the exponents m and n will get added. Here a is any integer and except 0, of course the base cannot be 0 in this case, and m and n are whole numbers. Let's see examples for this law. So let's take one example. Suppose I need to simplify this. Now many students can argue, okay, this is like pretty simple. I can do 3 square as 3 times 3 and 3 exponent 4 as 3 multiplied by itself how many times? 4 times. 3 times 3 is 9 and 3 multiplied by itself is 81. 4, when 3 is multiplied with itself like 4 times, it's 81, and my answer is 729. But if I do the same question using this above law, my example would become, now are the bases same? 3 and 3. So it will become, the base stays the same, but the exponents 2 and 4, they will get added. So it will give me 3 exponent 6, and now my power is 3 exponent 6. So it means 3 is being multiplied by itself how many times? 6 times, and my answer is 729. Of course the answer is same, 729, 729. But this law, with this law, the problem becomes comparatively easier, and that we will see in many more examples in my next videos when there will be the expressions with multiplication, division and power of the power. At that time this law would make more sense. Let's take some more examples for this law. So my next example would be, let's simplify this. Negative 2 exponent 2 multiplied by negative 2 exponent 4. The bases are same, negative 2, negative 2. So according to the law, the base remains the same and the exponents 2 and 4 will get added, which will give me negative 2. Let's put the bracket for a more neater look. Negative 2, 2 plus 4, 6. And that means negative 2 is being added with itself how many times? 6 times. And this one, and it will give me 2 to 4 times 2 8 times 2 16 times 2 32 times 2 64, and that's my answer for this problem. I hope this first law is clear. Now let's do the second law of exponents, and that second law is law for the quotient of powers. As the name is suggesting, quotient, it means now our law is for the division. It deals with the division. So if I have the powers with the same base, am divided by an, we have the powers with the same base, then the base stays the same and the exponents m and n, they get subtracted. So in the first law, when we were multiplying the powers with the same base, the exponents get added. But in this case, when we are dividing the powers with the same base of a, the exponents get subtracted. A is an integer except 0, and m and n are whole numbers. But in this case, there is a condition on the exponents. It means my m will be greater than equal to n. This first exponent will be greater than equal to, will be more than or equal to the second exponent n. Let's take an example for this quotient of powers now. So if I need to evaluate 4 exponent 6 divided by 4 exponent 3, if I will do it in the conventional way, like, okay, 4 is being multiplied with itself how many times? 6 times. So let's write it 6 times, and then it is divided by 4 cube. That means 4 multiplied by 3 times. Now let's simplify this expression. 4 and 4 can be simplified because 4 divided by 4 is 1. 4 divided by 4 is 1. 4 divided by 4 is 1. So I am left with these 3 these 3. So 4 times 4 times 4, and that will give me the answer as 64. But if I will do the same question using the law, I will get, let's rewrite it. So this will be, the base stays the same and the exponents get subtracted, and this. Now see, now compare how the question suddenly becomes easier. Less number of steps, and of course less time. So 4 cube is 4 times 4 times 4, and the answer is 64. Let's take one more example. Let's evaluate example 2. Let's evaluate negative 3 exponent 7, and my next power is negative 3 to the exponent 5. So if we will do with the law, the base stays the same and the exponents get subtracted, and my answer is negative 3. 7 take away 5 is 2, and this becomes now pretty simple. Negative 3 times negative 3 is equal to 9. So these laws help us to make our expressions easy and less time to solve the given question. So let's take one example in which both these laws can be combined easily. Example 3. So let's take this. 2 exponent 4 times 2 exponent 6 divided by 2 exponent 8. Now let's apply the laws of exponent. In the first part, I can easily apply the first law of the product of powers. Is the base same? Yes, the base is same too. And now they are being multiplied, so the powers will get added. So 4 plus 6. Let's write this term as it is. Now 2, 4 plus 6, 10. And the next term is same. And now we are done with this multiplication part, and now my second law comes into effect, the law of the quotient of powers, where the bases are same and they are being divided. So of course my exponents will get subtracted. So 10 minus 8. What is 10 take away 8? It's 2, and 2 square is of course 4. And see how the problem becomes so easier with the help of the laws of exponents. These were just the first 2 laws of the exponents. We will be covering the other 3 laws in our next video. I hope these laws are clear. So if you want to learn more about the laws of exponents, stay tuned. Please like and subscribe to my channel. Good luck with your math practice, with your math GED exam. Thank you so much for watching. Bye bye.